All right, let's take two here. Hopefully this works. If not, it's the computer program. So, hello, ladies and gentlemen. All right, let's hop back into this. Take two. This problem here is probably the easiest one because I'm giving you the genotypes. You didn't need to read anything to make the genotypes. I'm simply giving these to you. So, once I give you the genotypes,
no, he's close. He's close. Maybe in color.
Nope. It's just I don't think this. All right. Anyway, here we go. So I'm giving you two of the genotypes. You then must use the FOIL method, which I had talked about. First, outer, inner, last. So we're going to cross the first P with the first R. So big P, big R. I'm going to put that right there. The O, outer P, outer R. Outer P, outer R. So it's going to be big P, big R. What's the I mean? Inner P, inner R, which is inner P, inner R. So again, it's two dominant alleles being passed on. And the last P and the last R is this. So therefore, guys, based on the fact that this is a completely dominant genotype, we know that the only possible combination is that the father can only pass on dominant alleles.
Doesn't matter like if they go on the top or the side.
No. Question was, does it matter if these go on the top or the side? Does not matter. Just understand that these are the possible combinations of these alleles within the gametes, within the sex cells. All right. Next one. We have the next parent. FOIL method. First P, first R. So this is lowercase p, lowercase r. This is all going to end up being lowercase p, lowercase r, based on the combinations of alleles. So the first P and first R, the outer P and the outer R, the inner P and the inner R, and the last P and the last R, we are going to get all recessive traits. The next step now is to combine them. So if this sperm were to fertilize this egg, the resulting offspring would be big P, big R, little r. Okay? If this sperm were to fertilize this egg, the resulting alleles would be big P, big R, big R. And we can go through, and this one's super easy because we have completely homozygous traits. We have homozygous dominant for the first parent, homozygous recessive for the second parent. So therefore, guys, any combination of sperm and egg that we do here, they're all going to be the same. So they're all going to turn out to be big P, big R, little r. All right, so I'm just going to do this. And therefore, I'm just going to draw an arrow all the way over, meaning that they're all the same all the way across. All right? So now the question is, what are the expected phenotypic ratios and percentages in this problem? So remember, these are genotypes that you see within the box. The phenotypes are the actual, the physical expression of that trait. So since they're all the same, big P, big R, little r, we know it's going to be purple and what?
Purple and round.
Purple and round. So it's going to be 100% purple / round. Okay? So there it is. Question on the first one. Let's move on to number 2 then. Next one. It's same setup, guys. We have to use, since the dihybrid cross, we have to use the FOIL method. F stands for first. We are crossing the first P with the first R. Capital P, capital R. And again, this is nice and easy to understand because this whole, the genotypes of this is all homozygous dominant. So whatever the combination is, it's all that they're going to be capital alleles. So I can go right across and say big P, big R, big P, big R, big P, big R. Because any combination that you do here with the P's and R's results in dominant alleles. Okay? Now, we must then look at the second parent and do the FOIL method. First P with the first R, which is going to be big P, big R. Outer P and outer R. Outer P, outer R. This one is going to be big P, little r. I, inner P, inner R. So that's going to be lowercase p, dominant R, and then finally last P and last R is going to be small p, small r. Now we must combine them, which means if this sperm fertilizes this egg, the result would be big P, big R, big R. That's what the genotypes of that offspring would be. If this sperm, you guys like how I draw my sperm cells?
I like them.
Good. Little tails, you got to do it. Same case. Since these are all dominant, this is going to be big P, big R, big R. I'm going to just draw an arrow all the way across. They're all the same combination within the sperm cell, so therefore, if it fertilizes this egg, they're going to be the same all the way across. Next row here is if this sperm cell fertilizes this egg cell, it's going to be big P, big R, small r. If this sperm cell fertilizes this egg cell, it's going to be big P, big R, small r. This case, it's going to be the same. It's going to be the same thing all the way across because they are all the sperm cells are the same. You're seeing how this starts to get a little tedious here. Big P, big R with little p, big R. We're going to get big P, small p, big R, big R. These are going to be the same all the way across because the sperm cells are all the same. And finally, the last one is going to be big P, little p, big R, small r. And again, these will be the same all the way across because the sperm cells are all the same alleles. So if this is the case again, we are going to have every single one of these is going to be purple and what? Purple and round? Round's the dominant?
More or less.
Purple and round. Okay? So any questions with those? All right, let's move on here. This is still going quite slow. I'm going to skip over number 3 here just because it's the same basic setup. You have to do FOIL for both of these, get the gamete combinations on the top and on the side, and combine them. As I went around, a lot of people had questions with number 4, so let's look at number 4. The only difference between number 4 and numbers 1, 2, and 3 is I did not come out and give you the genotypes. You have to do a little bit of reading here and understand what the vocabulary says in order to understand the genotypes. It says a heterozygous long-stemmed white plant is crossed with a homozygous purple short-stemmed plant. First off is this. What does heterozygous mean? Different. So we're going to have different alleles for long stem. I don't have the, what's the letter that they're showing for stem length? L. So if it's heterozygous for stem length, we're going to have big L, little l. Heterozygous, long-stemmed, white plant. Is white recessive? Okay, so what do they use for color? P? Yeah. So if it's white-stemmed, it's got to be recessive. That's one parent genotype. Is crossed with a homozygous purple short-stemmed plant. So purple is dominant. So therefore, we are going to have. Well, let's do this. I want to keep the letters in the same order.
I don't like using these. It's too hard to like.
Then don't. I don't care what letters you use. Doesn't matter.
Too hard to like.
So let's. It is. I get it. So don't use numbers. Use letters. So if we are doing homozygous purple short-stemmed, what did they use for? They used L. So short stem, I'm assuming, is recessive. Little l, and it says homozygous, which means the same for purple, and we know purple is dominant, so it has to be big P, big P. All right, so that's how we get our genotypes for those. Now it's just like the problems up above. We need to do the FOIL method in order to figure out what the gametes are going to be. So first L, first P. First L, first P. So we're going to do big L, small p. Outer L, outer P. So it's going to be, again, big L, small p. You got it? The O is the outer L and the outer P. The I is the inner L and inner P. So it's going to be small l, small p. And the L is the last L in the last P. So again, it's going to be small l, small p. Yes. Yep. So this is the gametes for one of the parents, the other gametes. Same thing, FOIL method. First L, first P. So therefore, it's going to be small l, big P. In this case, it's nice and easy, because since they're both homozygous, they're all going to be small l, big P. Because whatever your combination is, it's all going to be little l with the big P. Okay? So now, again, I'm going to say the same thing I've been saying. If this sperm cell fertilizes this egg cell, we are left with the genotype of big L, little l, big P, small p. If this sperm cell fertilizes this egg cell, we are left with big L, big P, small p. If this sperm cell fertilizes this egg cell, we're left with little, big, little. And the same thing here. Little, big, little. So any questions with that? Now, we're going to go on to the next possible combination here. If this sperm cell fertilizes this egg cell, it's going to be the same. Yep. So technically all of these are going to be the same. I mean, as far as up the top. So big L, big P, small p, little, big, little, and little, big, little. Oh. Questions with that? All right. They're all going to technically be, they're all going to end up being the same. So I'm going to draw an arrow down like this. That's fine. I get it.
The hardest part of this is understanding the wording.
The wording. That is definitely the hardest part. Absolutely. Yep, but that's an important part, though, guys. Roz made a very astute observation. She said the hardest part is understanding the wording. Yeah, you're right, but you're going to have to be doing problems like this to show me that you understand the vocabulary. All right? So again now, what are the expected phenotypic ratios and percentages in this problem? Well, if we look here, big L, small l, big P, little p. What's that going to look like? It's going to be long and purple. So I can say long and purple. It's going to be 8 out of 16. So it's going to be 50%. These next two columns, they're all the same too. So therefore, it's going to be short and purple. And that's going to be 50%. Yes?
For the next one,
Yep.
you said tall. So were we just supposed to assume you meant long?
Yeah. Yep. So any questions with number 4? Would you guys like me to do 5? It's the same basic thing. You need to understand that what homozygous means and what heterozygous means, and which ones are going to be considered dominant and recessive, which I gave you the key up above. The word part? Sure. Yeah. I will. So the question was, can I just go over the wording here and tell me and go over what the genotypes are going to be? Yep.
It says a white flowing short plant. So that was kind of confusing. I didn't know about like flowing.
Oh, flowering. I forgot to put the R in. Little typo.
Yeah,
Yep. So a white flowering short plant is crossed with a heterozygous purple and homozygous tall plant. So White flowering. White's recessive, correct? So therefore it's going to be little p. Short plant. So short is recessive. So what's the letter? Little l. Times it is crossed with a heterozygous purple. So big P, small p, and homozygous tall, which is dominant, big L, big L. Okay? And then you're going to go through, do the FOIL method, and then you can figure out what your genotypes and phenotypes are from that. You're going to be doing something you're going to be doing something a little bit more interesting today. Yes, but you will be doing those, just not yet. Yes. You do. So here's the deal, guys. I'm going to give you this option, and I'll take a class vote. So the rest of this, again, it was just setting up your own Punnett squares. I give you the genotypes, so that the last part was pretty easy. Come on here. This has been super slow with this recording program. It's working, but it's just everything's delayed when I'm recording. So here's the deal. I have 2 activities planned today. One is to finish up the dihybrid crosses as it continues to scroll, where, holy moly. Yeah, these are just more advanced word problems as far as the dihybrid crosses. So here's the deal. We can either give you time to work on this now, or you can do this for homework. But here's the deal. The other activity is we are going to be doing the interpersonal section of the task rotation, which is definitely a more fun thing to do, where you are going to be figuring out what your child would look like if you were to cross your specific traits with someone else in the room. So let me ask this. Show of hands. Who wants? Both are going to get done.
Okay, wait, I have a question.
Regardless.
Would we do that for homework?
No. Well, hold on. Let's do this. I'm not even going to give you a vote. This is going to be homework. Decided. Done. Dictator rules. Hold on. Let me just do this.